Electricity is a fundamental aspect of our modern world, powering countless devices and systems we rely on daily. Understanding the basic principles of electricity is crucial for anyone working with electrical systems or simply wanting to comprehend how things work. This explanation will cover key concepts like voltage, current, resistance, and power. Let's begin with voltage, also known as electrical potential difference. Voltage is the driving force that pushes electric charge through a circuit. Think of it like water pressure in a pipe. The higher the pressure voltage, the more water charge will flow. Voltage is measured in volts. A common example is a standard household outlet in the United States, which typically provides 120 volts. Higher voltage systems, such as those used in industrial settings, may operate at 480 volts or even higher. Next is current. Current refers to the rate of flow of electric charge. It's essentially the amount of charge passing a given point in a circuit per unit of time. Using the water analogy, current is like the amount of water flowing through the pipe. Current is measured in amps. A small electronic device might draw only a few milliamps, while a large appliance like an air conditioner could draw several amps. The relationship between voltage and current is described by Ohm's law. After that is resistance. Resistance opposes the flow of electric current. It's a property of materials that hinders the movement of charge. In the water analogy, resistance is like a constriction in the pipe that limits the water flow. Resistance is measured in ohms. A thin wire offers more resistance than a thick wire of the same material. Resistors are components specifically designed to provide a certain amount of resistance in a circuit. Ohm's law is a fundamental equation that relates voltage, current, and resistance. It states that voltage volts equals current amps multiplied by resistance ohms, or volts equals amps times ohms. This law is essential for analyzing and designing electrical circuits. If you know any two of these values, you can calculate the third. For example, if a circuit has a voltage of 12 volts and a resistance of 6 ohms, the current flowing through the circuit would be 2 amps. 12 volts / 6 ohms equals 2 amps. Power is the rate at which electrical energy is transferred or used. It represents the amount of work done per unit of time. Power is measured in watts. A light bulb, for instance, might be rated at 60 watts, indicating the amount of electrical energy it consumes when lit. The relationship between power, voltage, and current is given by the equation power watts equals voltage volts multiplied by current amps, or watts equals volts times amps. Using the previous example with 12 volts and 2 amps, the power dissipated in the circuit would be 24 watts. 12 volts times 2 amps equals 24 watts. Electrical circuits can be classified into two main types: series circuits and parallel circuits. In a series circuit, components are connected one after another along a single path. The current is the same through all components in a series circuit, while the voltage is divided among them. If one component fails in a series circuit, the entire circuit is broken and no current flows. In a parallel circuit, components are connected along multiple paths. The voltage is the same across all components in a parallel circuit, while the current is divided among them. If one component fails in a parallel circuit, the other components continue to function. Understanding these circuit configurations is crucial for troubleshooting and designing electrical systems. Electrical safety is paramount when working with electricity. Always take precautions to avoid electric shock, which can cause serious injury or death. Never work on live circuits. Always disconnect the power source before performing any electrical work. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards of electricity and follow all safety regulations. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from excessive current. Fuses are sacrificial devices that melt and break the circuit when the current exceeds a certain level. Circuit breakers are resettable devices that trip and interrupt the circuit when the current exceeds a certain level. These devices are essential for preventing fires and damage to equipment caused by overloads and short circuits. Grounding is another important safety measure. Grounding provides a low-resistance path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electric shock. All electrical equipment should be properly grounded according to the National Electrical Code or NEC. Wiring diagrams are essential tools for understanding and troubleshooting electrical circuits. These diagrams show the connections between various components in a circuit, including wires, switches, receptacles, and loads. There are different types of wiring diagrams, including schematic diagrams, which use symbols to represent components, and wiring diagrams, which show the physical layout of the wires and components. Being able to read and interpret wiring diagrams is a valuable skill for anyone working with electrical systems. Electrical components are the building blocks of electrical circuits. These components include resistors, capacitors, inductors, diodes, transistors, and integrated circuits. Resistors, as mentioned earlier, provide resistance to the flow of current. Capacitors store electrical energy in an electric field. Inductors store electrical energy in a magnetic field. Diodes allow current to flow in only one direction. Transistors act as switches or amplifiers. Integrated circuits, or ICs, contain complex circuits on a single chip. Each of these components has unique properties and applications in electrical circuits. Measuring electrical quantities is essential for troubleshooting and analyzing electrical circuits. A multimeter is a versatile tool that can measure voltage, current, and resistance. To measure voltage, connect the multimeter in parallel with the component you want to measure. To measure current, connect the multimeter in series with the component you want to measure. To measure resistance, disconnect the component from the circuit and connect the multimeter across it. Always use the correct settings and ranges on the multimeter to avoid damaging the meter or the circuit. Understanding electrical codes and regulations is crucial for ensuring the safety and compliance of electrical installations. The National Electrical Code or NEC is a widely adopted standard for electrical wiring and equipment in the United States. The NEC provides detailed requirements for various aspects of electrical installations, including wiring methods, grounding, overcurrent protection, and equipment installation. Compliance with the NEC is essential for preventing electrical hazards and ensuring the safety of people and property. Electrical troubleshooting involves identifying and resolving problems in electrical circuits. A systematic approach to troubleshooting can save time and effort. Start by gathering information about the problem, such as when it occurs and what symptoms are present. Then use a multimeter to measure voltage, current, and resistance at various points in the circuit. Compare these measurements to the expected values to identify the source of the problem. Once you've identified the problem, you can take corrective action to fix it. Electrical power distribution is the process of delivering electrical power from the source to the end users. Power is typically generated at power plants and transmitted over high-voltage transmission lines to substations. At substations, the voltage is stepped down to lower levels for distribution to homes and businesses. The distribution system consists of feeders, which carry power from the substation to distribution transformers, and branch circuits, which carry power from the distribution transformers to individual loads. The design and operation of electrical power distribution systems are complex and require specialized knowledge. Renewable energy sources, such as solar and wind, are becoming increasingly important in the energy mix. Solar panels convert sunlight into electricity using the photovoltaic effect. Wind turbines convert wind energy into electricity using rotating blades. These renewable energy sources offer a clean and sustainable alternative to fossil fuels. However, they also present challenges in terms of intermittency and grid integration. Understanding the principles of renewable energy and their integration into the electrical grid is crucial for the future of energy. Electrical safety audits are conducted to assess the safety of electrical installations and identify potential hazards. These audits typically involve a visual inspection of the electrical system, as well as testing of various components and equipment. The audit report provides recommendations for correcting any deficiencies and improving the safety of the electrical system. Regular electrical safety audits can help prevent accidents and ensure the safety of people and property. Power quality refers to the characteristics of the electrical power supplied to a load. Poor power quality can cause equipment malfunction, data loss, and reduced efficiency. Common power quality problems include voltage sags, voltage swells, harmonics, and transients. Power quality monitoring and mitigation techniques can help improve the reliability and performance of electrical equipment. Energy efficiency is the practice of using less energy to perform the same task. Improving energy efficiency can save money, reduce pollution, and conserve natural resources. There are many ways to improve energy efficiency in electrical systems, such as using energy-efficient lighting, motors, and appliances. Energy audits can help identify opportunities for energy savings. Automation and control systems are used to automatically control and monitor electrical equipment. These systems can improve efficiency, reduce costs, and enhance safety. Common automation and control systems include programmable logic controllers or PLC, distributed control systems or DCS, and supervisory control and data acquisition or SCADA systems. The design and implementation of automation and control systems require specialized knowledge and skills. Electrical design software is used to create and analyze electrical designs. This software can help engineers to design safer, more efficient, and more reliable electrical systems. Common electrical design software includes AutoCAD Electrical, ETA, and SKM Power Tools. These tools can automate many of the tasks involved in electrical design, such as creating wiring diagrams, performing load calculations, and simulating circuit behavior. The electrical testing equipment is used to test and troubleshoot electrical circuits and equipment. This equipment includes multimeters, clamp meters, insulation testers, and ground resistance testers. These tools can help technicians to diagnose problems, verify the performance of equipment, and ensure the safety of electrical systems. Proper use of electrical testing equipment requires training and experience. Electrical maintenance is the practice of regularly inspecting, testing, and maintaining electrical equipment to ensure its safe and reliable operation. Regular maintenance can help prevent equipment failures, extend the lifespan of equipment, and improve the efficiency of electrical systems. Electrical maintenance activities include visual inspections, cleaning, lubrication, testing, and replacement of worn parts. A well-planned electrical maintenance program is essential for any organization that relies on electrical power. Electric motors are used in a wide variety of applications, from powering small appliances to driving large industrial machinery. There are many different types of electric motors, including AC motors, DC motors, and synchronous motors. The selection of the appropriate motor for a particular application depends on factors such as the load requirements, the operating speed, and the power supply. Electric motors are an essential component of many electrical systems. Transformers are used to step up or step down voltage levels in electrical power systems. Transformers consist of two or more coils of wire wound around a common core. The voltage ratio between the primary and secondary windings is determined by the turns ratio of the transformer. Transformers are essential for transmitting electrical power over long distances and for adapting voltage levels to meet the needs of different loads. Electrical lighting is an important aspect of electrical design. Proper lighting can improve visibility, enhance productivity, and create a more comfortable environment. There are many different types of electrical lighting, including incandescent lamps, fluorescent lamps, and LED lamps. The selection of the appropriate lighting for a particular application depends on factors such as the light output, the energy efficiency, and the color rendering. LED lighting is becoming increasingly popular due to its high energy efficiency and long lifespan. Electrical safety training is essential for anyone who works with electrical equipment. This training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Electrical safety training can help prevent accidents and save lives. Many organizations offer electrical safety training programs that meet the requirements of OSHA and other regulatory agencies. The information presented here provides a basic understanding of electrical concepts.